Hello, ladies and gentlemen. This is Mrs. Poland for lesson 9.05 on the average rate of change. Before I actually start the notes part of the lesson, I just want to go over the definition of the average rate of change. So you could just follow along, you don't have to write it down. The average rate of change is a measure of how much the function changed per unit on average over a specific interval. It's derived from the slope of a straight line connecting the interval's endpoints on the function's graph. So here I have a graph of a cubic function, and if I'm looking for the average rate of change over the interval from -1 to 1, I would locate the endpoints of the interval, so -1, 0, and this other point, 1, 4, and then I would connect a line to those points, and I would calculate the slope. Well, you may remember the slope of the line. The formula is change of y over change of x. We could use a formula, or we can just, since this is a fairly straightforward example, look at the vertical change, so that would be 4 units, over the horizontal change, which would be 2 units, and get a slope of the line of 2. So the average rate of change over the interval from -1 to 1 would just be 2. So now let's do this more formally. The first skill we'll go over is actually from Algebra 1, Delta Math. Given the function defined in the table below, find the average rate of change in simplest form of the function over the interval from 2 is less than or equal to x is less equal to 5. The formal definition of the average rate of change is f of x2. That means you're going to look at the interval from x2 to x1, and we're going to look at that difference in our x value, and then evaluate the function at the x2 value, and then subtract from that the value of the function at the x1 value of the interval. So what does that mean? Let's look at the table and circle those points. So we're looking at the interval from 2 to 5. And I always start with my rightmost value. And remember, the x's go in the denominator, right? So what I normally like to do is I write them as points, and I put the rightmost point at top. And here's my x and here's my y. So I'm evaluating the function at 5. And from that, I'm subtracting the value of that function at 2. And it's going to be over the change in my x's, the 5 minus 2. So that's going to be 324 minus 12 over 3. That's 312 over 3. I'm sorry. Yeah, no, I was right. That's 312 over 3, or 104. You have to show a substitution into the formula. You can't just have 104 as the final answer. And you should label it as average rate of change. That's what I'm expecting to see. So that's how you evaluate the average rate of change from a table. We're now going to evaluate the average rate of change from an equation. So we have this equation, h of x is equal to -x squared plus f of x plus 4x plus 11. And we want to determine the average rate of change in the interval from 0 to 6. So the average rate of change is the change in our y values, right? So we're going to do h of 6. Again, I always start with my right, minus h of 0 over 6 minus 0. I always go right to left. I always start right to left. So the denominator is fairly easy. It's just 6 minus 0 is 6. But I actually have to evaluate this function at 6 and evaluate it again at 11. At 0, I mean. So we're going to show the substitutions into the formula. So negative 6 squared plus 4 times 6 plus 11. I would expect you to show the substitution. And you can either do this by hand, or you can use the calculator. So you should have a calculator with you to do the homework or to do the classwork. So we're going to first substitute 0 in for x. So 6 control var x. Oop. And now we're going to type in the function. So it's negative x squared. Hit tab. Then it's plus 4x plus 11. And when I do that, I get negative 1. And this one is fairly easy to do by hand. It's just 0 plus 11 or 11. And make sure you go in order. So that's negative 1 minus 11. The order matters. So negative 12 over 6 is negative 2. So that's the average rate of change from the interval 0 to 6 for h of x. Number 3. So now we're going to be doing it graphically. So we're given this function and we want to find the average rate of change again over the interval from 2 to 3. Again, I always, when I evaluate this, determine the average rate of change, do the rightmost point first, or evaluate the rightmost point first. I try to be consistent. It's helpful. So the average rate of change, I would locate those points. So that would be 2, negative 4, and 3, negative 8. It may be even helpful to write it down. So I'm evaluating the function at 3, and from that I'm subtracting out the value of the function at 2 over 3 minus 2. And again, this is the kind of work I would expect and the Regents would expect. And so here's my x, here's my y. So it's negative 8 minus, don't forget that negative 4 over 3 minus 2. You have to be careful to be consistent. So negative 8 plus 4 is negative 4 over 1, or negative 4. Problem 4. This is a very common problem on the Regents. What they want you to do is evaluate 3 different functions: g of x, f of x, and h of x. And they're asking you to evaluate it on the interval from negative 2 to negative 1, and then to arrange it, order it from least to greatest, from smallest to largest. Okay, so again, we're looking at negative 2 to negative 1. So we're going to start with g of x. It's really important with these that you label which average rate of change you're doing. So I normally use a subscript, say a or c. Don't go g of x, go a or c subscript g of x. And we're going from negative 2 to negative 1. Remember, this is the x values. X goes in the denominator, y goes on top. Think slope. So you're going to evaluate g of negative 1, because again, I always do right first, minus g of negative 2 over negative 1 minus a negative 2. So g of negative 1 is 17. G of negative 2 is 26 over negative 1 minus a minus 2 becomes plus, so that's 1. And so that turns out to be negative 9. So that's the average rate of change of g of x. Again, really make sure you notate which average rate of change is which. I'm going to do f of x, the average rate of change of f of x in red. And again, we're looking from negative 1. So I think I'm going to write down that point to, oh, I'm sorry, I'm wrong. we're going from negative 2, so negative 2 comma 6 to negative 1. And I'm going to put the rightmost point on top. So negative 1 and negative 2. So that's the second coordinate. So the average rate of change of f of x is f of negative 1 minus f of negative 2 over negative 1 minus a minus 2. So f of negative 1 is negative 2. F of negative 2 is 6 over 1 minus a minus 2 is 3. Actually, this should be a negative 1. So this is positive 1. Sorry about that. I'm glad I caught that. And that gives me a value of negative 8. Okay, and one more. So now I have to do h of x. I'll do that in green. So the average rate of change of h of x, and again, we're evaluating it over that same interval, and I always do rightmost point first. So it's going to be h of negative 1 minus h of negative 2 over negative 1 minus a minus 2. So I have to evaluate this function at h of negative 1. So wherever you see an x, you're going to substitute it in. And again, you could use the store feature of the calculator, but to save time, I am just going to write down the correct answer, and that should be negative 27. And now we're going to evaluate it at negative 2. So the store feature may save you some grief with arithmetic. It's a little faster. And when we enter that in the calculator, you should get negative 25. So we're going to carefully substitute in. So negative 27 minus a negative 25 over negative 1 plus 2 is positive 1. And that turns out to be negative 2. So you're evaluating from least to greatest. So negative 9 is the smallest. And negative 8 is going to be larger than negative 9, so that's going to be in the middle. And the negative 2 is going to be the largest. So you actually have to show from least to greatest. So the average rate of change for g of x is going to be less than the average rate of change for h of x. It's less than the average rate of change for f of x. And that would be the answer. I think I just had to order the function, so I think you could have just written g of x, and this is, I think it's multiple choice. G of x, h of x, and f of x. I didn't catch that it was multiple choice. So that would be I have this backwards. Sorry about that. Negative 2 is largest, and I wrote it down wrong. Hold on. I had the correct information. I just reordered it. So the negative 2 is, it's negative 9, negative 8, negative 2. So that was g of x, f of x, sorry about this, and h of x. I had the right information, but I sorted it wrong. Okay, so that's this choice. Skill number 5. So you're given this interval and you're given a graph. And what they want you to do is they want you to compare the intervals and find which one has the smallest average rate of change. Now, I'm going to do it the long way first, but there is a shortcut to it. Basically, what you're doing is you're finding the average rate of change for each one. So let's do the average rate of change first for A. So you're looking at the interval from 0 to 1. So if you're looking at the interval from 0 to 1, remember it's the change in y over change of x. So we're looking at the point 1, 6, and 0, 0. So that would be 6 minus 0 over 1 minus 0, which is 6. So that's A. And B, I'll switch colors. You're going from 1 to 7. So again, y goes on top, so it's the y first. So that's going to be 7, 13, and 1, 6. So that's going to be 13 minus 6, y's are on top, over 7 minus 1. So that's 7 over 6. And I'll do the next one in green, the C. So now we're looking at the interval from 7 to 14. Again, y's are first. Remember x, y. Y's are on top, x, y. So that would be, so like the average rate of change in the interval from 7 to 14. So that would be 22 minus 13 over 14 minus 7. And that simplifies to 9 over 7. And I think, thank God it's only one more. I'll do that in like that brick red. So now we're looking at the average rate of change, and we're looking at the interval from 14 to 25. Again, you're looking at y's on top. So that would be 27 minus 22 over 25 minus 14. And so that simplifies to 5 over 11. And they want which is the smallest. So which one of these numbers is smallest? Well, 6 is largest. 7 over 6 is slightly over 1. 9 over 7 is slightly over 1. It's choice D, okay, because that's the smallest. Now, you may have been able to tell visually because from 14 to 22, it's very apparent that it's a very less steep slope. But sometimes you can't tell just by looking at it, and you really have to calculate it algebraically. Okay, and the last problem is a word problem from the August 2016 Regents, number 31. The distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows the stopping distance for various speeds. Determine the average rate of change of braking distance in feet between one car traveling at 50 miles per hour and one car traveling at 70 miles per hour. Okay. And then they want you to explain what the rate of change means as it relates to the braking distance. So we're looking at the interval from 50 to 70. Okay, so we're looking at the average rate of change, and I'm going to represent the points as the subscript. And again, I always do the rightmost point first, so the 70 first. Remember, the x's, the y's are always on top, the x's are always in the denominator. Sometimes students mix them up, and you would get 0 credit on my test as well as 0 credit on the Regents. So we're evaluating this function at 70, Then we're evaluating this function at 50 and then subtracting the difference over 70 minus 50. So that's 306.25 minus 156.25 over 20. And so that's equal to 150 over 20, which is 7.5. And you have to have units when you're doing these real life problems. So what's on top? It's the y, it's the feet. So it's 7.5 feet over one. You don't have to write the one, but feet. You know what? I'm going to write it this way. 7.5 feet per every mile per hour. So the units in the denominator are the x. Remember, this is the x, this is the y. So now we have to interpret. Now, when you're interpreting, you should start off with on average. And before I go into the interpretation, what I normally like to do is I like to think about what average rate of change is. It's really the slope. So it's the change of y over the change in x. So it's the change. What is our y? It's the change in the distance that you traveled in feet over the change in speed. So again, for every additional, I always start off with the denominator. So this is feet and this is mile per hour. So on average, for every 1 mile per hour increase in speed, I'll write it this way. The distance needed to brake or needed to stop increases 7.5 feet. And that's a way of interpreting it. Have a great day. Make sure you start your Delta Math, and I will see you on Monday.